Professor Belfrost's science class is back.
Hi, welcome back again to my class, and today you're on my mathematics class, okay? Yeah, first I want to congrats you. You are on new chapter now, okay? So this is a new achievement for you too, okay? That's great of you. So we'll discuss today new chapter, which is equations and inequalities, the first part. Actually, this is just another, uh, this is just another part of algebra learning. So yeah, so today's discussion will focus on one story reflection. So this character was staring at a fly crawling on the ceiling when he realized that he could describe the fly's location in relation to the perpendicular lines formed by the adjacent walls of his room. So he viewed the perpendicular lines as horizontal and vertical axes, and further by dividing each axis into equal unit lengths, the Descartes saw that it was possible to locate any object in a two-dimensional plane using just two numbers, which is the displacement from the horizontal axis and the displacement from the vertical axis. And while there is evidence that the similar ideas of great system existed centuries earlier, yeah, this is it was Descartes who introduce the components that comprise the Cartesian coordinate system we use now. So a grid system having perpendicular axis, which is of x-axis and y-axis, respectively horizontal and vertical. So the Cartesian coordinate system, also called the rectangular coordinate system, is based on two-dimensional plane consisting of the x-axis and the y-axis. Although we can expand to also include the z-axis, which is the three-dimensional. Okay, so perpendicular to each other, also for the three-dimensional layer is also perpendicular to each other. The axis divide the plane into four sections or called a quadrant. So the quadrants are numbered counterclockwise as shown in the figure on the next slide. Okay, tada! So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the side of the plane is the point at which the two axes cross. So it known as the origin or point 0, 0. So from the origin, each axis is further divided into equal units, increasing positive number to right on the axis up the y-axis, and also decreasing one is negative numbers to the left of the x-axis and down the y-axis. So the axis extend to the positive and negative infinity as shown by the arrowhead in the right side figure, right bottom, right top. So each point in the plane is identified by its x-coordinate or horizontal displacement from the origin, and also the y-coordinate or the vertical displacement of the from the origin. Okay, so together we'll write them as an ordered pair indicating the combined distance from the origin, which is xy form. Okay, so an ordered pair is also known as coordinate pair because it consists of x and y coordinates. So for example, we're going to represent the point 3 minus 1 in the plan by moving 3 units to the right and 1 unit down in a vertical direction as shown in the figure. Okay, so when we divide the axis into equal space increments, that the x-axis may be considered separately from the y-axis. In other words, that while the x-axis may be divided and labeled according to consecutive integers, that the y-axis may be divided and labeled by increments of 2 or 10 or 100. It is up to you. It's your choice. Okay, so in fact, the axis may represent other units such as years against a balance in a saving account, or quantity against cost, and so on. Okay, so consider the rectangular coordinate system primarily as a method for showing the relationship between two quantities. So you can plot a set of points to represent an equation. So when such an equation contains both an x variable and a y variable, that is called an equation in two variables. And this graph is called a graph in two variables. And any graph on two-dimensional plane is a graph in two variables. So suppose, okay, first example, we want to graph the equation y equals 2x minus 1. And we can begin this by substituting a value for x into the equation and determining the resulting value of y. Each pair of x and y values, which is possible. Actually, you can take your own values, actually, that we will plot. And here is the list of value from x minus 3 to 3 and your resulting values. And here's the plot. Actually, you can extend this to more x values, for example, from minus 5 to 5, okay, or from greater value, or you can skip, okay. You can make a greater grid, okay. You can skip. For example, you take minus 10, minus 5, 0, 5, 10. It's up to you, actually. I don't mind, okay. So note that the x values chosen are arbitrary, okay. So this is a point. Are arbitrary, regardless of the type of equation we are graphing. And of course, some situations may require particular values of x to be plotted in order to see a particular result. Otherwise, it's logical to choose values that can be calculated easily, and it's always a good idea to choose values that are both negative and positive. And there's no rule dictating how many points to plot, although we need at least 2 to graph a line, okay? And keep in mind that the more points we plot, the more accurate we can sketch this graph. This actually especially for non-linear equation, okay. If we are plotting linear equation, there is nothing to worry if we only take 2 points. But for example, we have quadratic equation or exponential equations or something that is on greater degree equation, then the more points that we take, this the better the line that we draw express the proper value, okay. So if you are given an equation, you can plot the points to make a graph by following these 5 steps. I want you to read it by yourself. I will not read it for you. So the intercepts of a graph are points at which the graph crosses the axis, and the x-intercept is the point at which the graph crosses the x-axis. And here the y coordinate is 0. Also the same thing apply for the y-intercept. Y-intercept is the point at which the graph crosses the y-axis. Here it means that the x-coordinate is 0. So to determine the x-intercept, we set y equals to 0 and solve for x. And similarly, to determine the y-intercept, that we set x equals to 0 and solve for 1. For example, let's find the intercept of the equation y equals 3x minus 1. So to find the x-intercept, that we set y equals to 0. So 0 equals to x minus 1, which gives us x equals 1/3. Okay. To find the y-intercept, we set x equals 0, and it gives us y equals minus 1. So that's it. The x-intercept is 1/3 0, and the y-intercept is 0 minus 1. So we can confirm our result by sketching it. So given an equation, find the intercept by following this rule. Okay, now let's do official practice. Okay. Also, this is a little exercise. Okay, so plot the points when it's 2, 4, 3, 3, and 0, minus 3 in the plane. Actually, this is very easy, right? This is like a kid's problem. Okay, so here's the description of what we should do to plot the points on our Cartesian plane. And here's the graph of the plotted points. That please note that our coordinate is 0, the point must be on an axis. If the x coordinate is 0, then the point is on y-axis, and if the y coordinate is 0, then the point is on the x-axis. Okay, the second example. Graph the equation y minus x plus 2 by plotting point. So what we need to do first is construct a table. Okay, construct a table is a must. We can choose every value of x that will make it easy to plot the table. To make the plot. I mean, here I choose minus 5, minus 3, minus 1, 0, 1, 5, 3. You see? I didn't choose it 1, 2, 3, 4, 5. I just arbitrarily pick some interval between the x value and create the table. Yeah, this is what you can do. Now we just plot the points and connect them to make a line. And the plot can be seen as shown in the slide. Number 3, example. Find the intercepts of the equation y equals minus 3x minus 4, and then sketch a graph using only the intercepts. Yeah, actually easy. X-intercept, by using the method I've taught you before, it is minus 4/3, and the x-intercept is, so the x-intercept is minus 4, 0. For the y-intercept, it is minus 4. Okay, so 0 minus 4. And by plotting both points and drawing a line, then here's the figure. Okay, so derived from the Pythagorean theorem, or Pythagoras theorem, it's up to you. So the distance formula is used to find the distance between 2 points in the plane. And the Pythagorean theorem, which is a squared plus b squared equals c squared, is based on a right triangle, where b are the lengths of the side of adjacent right angle, and the c is the length of the hypotenuse. Okay, so here's the figure. So the relationship of the sides, which is the absolute value of x2 minus x1 and the absolute value of y2 minus y1, the side of D is the same as that of sides A and B to side C. And we use the absolute value symbol to indicate that the length is a positive number, because the absolute value of any number is positive. And symbol indicates that the length of the side of the triangle is positive. And to find the length C, just take the square root of the both side of the Pythagorean theorem. So it follows that D equals square root of the sum of x2 minus x1 squared and y2 minus y1 squared. So yeah, we don't have to use the absolute value here in this definition, because yeah, we have squared them. A number that is squared always positive, okay? So here's the example for you to understand the concept. So find the distance between the point minus 3 minus 1 and 2, 3. So yeah, it's very easy. First, let us look the graph, just sketch the point. Then connect the points to form a right triangle as shown. Then we can calculate the length by utilizing the Pythagorean theorem for the length, the distance that we have derived before, and yields d equals d equals square root of 41. Here's second example. I'll not read the narration. You read it by yourself. The question is simple. Find the total distance that Tracy traveled and compare this with the distance between her starting and final positions. So this actually has entered in physics realm. So actually there are something different between distance and displacement. You need to notice that these two terminology used, these two words, are completely different. So distance and displacement are completely different. Okay? Okay, so let's analyze the picture first. Let's look how Tracy is actually set up. Okay, so red dot. Okay, red dot. Okay. Okay, I've got it. Yeah, so first thing is to identify all the pairs. Okay, so we have 1 1, 5 1, 8 3, 8 7. And yeah, we calculate the distance that each grid unit. This is a very important note. So each grid unit represents 100 feet. 1,000 feet. I'm sorry. So yeah, the distance for the first step is 2,000 feet. For the second stop, the distance is 4,000 feet. For the third stop, it is 5,000 feet, and the fourth stop, it is 4,000 feet. So the total distance that she has traveled is just the sum of these 4 stops, which is 15,000 feet. But the displacement or the distance between her starting and ending point are different. We need to find this using Pythagorean theorem, and it yields us 10.63 units, or it is about yeah, you know it. Just convert it to feet. So 10,630.14 feet. Okay, so that's done for the first concept. Now the second concept. When the endpoints of a line segment are known, we can find the point midway between them, and this point is known as the midpoint, and the formula is known as the midpoint formula. So given the endpoints of a line segment is x, y, and y, y1 and x2, y2 respectively, then the midpoint formula is as shown. M equals xy, sum of x1 and 2 divided by 2, sum of y1, y2 divided by 2. So a graphical view of a midpoint is shown in the following figure on the next slide. And please notice that the line segment on either side of the midpoint are congruent. Okay, here's the example for you to understand the concept. Find the midpoint of the line segment with the endpoint 7, 2 and 9, 5. So actually, this is very simple. We just need to apply the formula to find the midpoint. Okay, so sum of 7 and 9 divided by 2 and sum minus 25 divided by 2, which gives us x is 8, the y is 3 halves. Second example, the diameter of a circle has endpoints minus 1, minus 4 and 5, minus 4. Find the center of the circle. So here's the solution. Yeah, very easy too, right? Okay, so the midpoint is actually the center. The center of a circle is the center of midpoint of its diameter. Okay, so the midpoint formula will get center point, which is, yeah, as shown, and it gives us 2 minus 4. Now let's discuss about linear equation. So what is a linear equation? It is an equation of a straight line written in one variable. The only part of the variable is 1. Linear equation in one variable may take the form x plus b equals 0 and are solved using basic algebraic operations. And we begin by classifying linear equation in one variable as one of three types: identity, conditional, and consistent. An identity equation is true for all values of the variable. Here's the example. 3x equals to x plus x. Actually, you know that this always be true because, yeah, 2x plus x will add to 3x. So it's just identity to itself, okay? So the solution set consists of all values. So all real values, actually all values, all numbers, okay, that make the equation to be true. While a conditional equation is true for only some values of the variable. For example, we have 3x plus 2, 3x minus 1. So after solving it, we know that the only x that will work for this equation is minus 4. So the solution set is consists of only one number, which is minus 4. And this is the only solution. And that we have solved the conditional equation. And now third type, inconsistent equation. So an inconsistent equation always results in a false statement. So for example, we are to solve 5x minus 15 equals 5 times subtraction of x 4 to the x. So we have the following, and we solve it: minus 15 not equal to minus 20. Okay, so actually there's no solution because this is an inconsistent equation. So solving linear equation in one variable involves the fundamental properties of equality and basic algebraic operations. So the following steps are used to manipulate an equation and isolate the unknown variables so that the last line reads x equal something if x is the unknown. Actually, there is no set order as the step use depend on what is given. But here's the 4 step that you must always have in solving for the x value. You may want to take screenshot. Okay, let's practice. So solve for following equation, which is 2x plus 7 equals 19. Yeah, so you just need to rearrange the equation, just perform the usual algebraic operation. And after perform the algebraic operation, you get that x equals 6. So 6 is the only solution to this equation. Now solve for following equation. 4 times x minus 3 plus 12 equals 15 minus 5 times x plus 6. Yeah. So first you need to apply distributive property. And after that, just simplify there. It results in 9x equals minus 50. So the final result, x is equals minus 15 or 9, or it is minus 5 true. Yeah. And actually, no, this is not the one that you need to do. Okay, so that's done for today first lesson on this chapter, equation and inequalities. Here's inspiration for you, quote for you. So William James once said, act as if what you do makes a difference, and it will do. It certainly will do. It does. So thanks for watching. Subscribe, give a like, comment, and share this video. I will be back in every Tuesday and Thursday. Don't forget to visit our official website, sciencewithxyz.unaworks.com, to access your free learning resource and also many interesting things there. Keep watching and be thoughtful. Goodbye. See you on the next episode.